let's ask Chad here, how do we work with second order ordinary differential equations? So, how to solve second order ordinary differential equations. So solving second order differential equations, ODEs, we go through it step by clear explanations. So the standard form would be this. So we would have coefficient 1 for the second degree derivative of y, then some function of x times y prime plus another different perhaps function of x times y equals another function of x. So yes, y double prime is second derivative of the function y that we're solving for, y first prime is first derivative. So the ODE is homogeneous or it is non-homogeneous. So if r of x is 0 here, then it's homogeneous. But if it's not 0, it's non-homogeneous. And constant coefficients are a nice example. That's nice situation to be in, because then we can solve it using exponential e to the x. So we form a characteristic equation like this. We basically rewrite it into a quadratic equation, and then we solve for the roots of the r. And then we put the roots here inside as coefficients for e to the ax, e to the bx, e to the r1x, e to the r2x form. And then we add linear combinations of those two, using some real coefficient c1, c2, the capital C1, c2, c coefficients. And we have alpha plus beta I if it's complex, so it's more complicated there. They don't fully explain on how it's done, but let's just now be satisfied with the real cases. With complex numbers, it's a little bit different, but we would have to ask chat to expand on that, but I'm not gonna type it. So if OD is non-homogeneous, that actually there's something not 0 on the other side, it gets harder. Alright, so you solve the homogeneous part, and then you need a particular solution. So basically you would take all the solutions we would get in the case that 0 is on the right side, like before, and then you need to do another thing and add it. So do a linear combination not only of the solutions in the 0 on the right side situation and add to it also, but also add to it the solution like there's something on the right side. So we have to reflect that and include it into the total linear combination solution. And yeah, so this would represent like the solution if there was 0 on the right side, and this is like because of the right side there's something. So we can use some methods. Again, that's matter of practice and needs expanded explanation. So here it's not expanded now, you would have to prompt it. And then there are some special cases. So in some special cases, even if it's not super simple, we can still find predictable solutions because it's a well-known form. So Cauchy-Euler equation looks like this. We can substitute y is x to the m and get some characteristic equation, and then basically get the solution similarly to when the coefficients were constant case. So, or we can use reduction of order, many methods, but that's to be expected. We have some examples here how it would turn out. So we would have, for example, this solution for such an equation. If it was non-homogeneous, another example, slightly different.